So in this question, we are tasked to find the volume of the solid of revolution generated by these two functions rotated around this line. The way we do that, like any other solid of revolution question, is we must first determine what method we're going to use. The way we do that is we look at how our functions are defined, what variable defines our functions. And looking here, I wrote it in red this time because I found that the blue didn't show up very well on the camera. So if we have f of x, that's defined in terms of x, g of x is defined in terms of x, and our axis of revolution is x equals some constant. In this case, that constant is 4, but it could be anything. But it's in terms of x, and so all of these are in terms of x, so we're going to use the shell method. If, like I've said before, if these two were defined in terms of one variable, and this were defined in terms of another variable, then we could no longer use the shell method without adapting our functions to match. Instead, we'd be forced to use the disk method. But these all do match, and so we can use the shell method, so that's what we're going to do. The first step is to find a domain, because we're not given a domain for this function, empty. So the way we find this is we set our two functions equal to each other and find where they cross, because we're trying to find the area in between the graphs rotated around this. So we have to find the area in between these graphs. So we set these equal to each other. We have x squared equals 4x minus x squared. Do not divide by x. You will lose one of your zeros. Instead, add x squared, subtract 4x, and you get 2x squared minus 4x equals 0. From here, we can divide by 2 and factor out an x, and I just did that in a single step. So I have x times x minus 2 equals 0. And from there we can solve, right there. So x equals 0 and x equals 2. And that is our domain. That's where these two functions cross each other. And we want the area in between them. And so our domain is x is a member between 0 and 2 inclusive. And from here, now that we know our domain, this is the values of x that generate the cross section here. So what we want to do is we want to find which of these two functions, f of x or g of x, is greater during this interval. The way we find that, one, you could use the graph, but I hate graphs. Two, you can use math, and I love math. So what we're going to do is we're going to find some value in between 0 and 2, and you should be proud of me. I did not put brackets this time. So some random c that is a member between 0 and 2, not inclusive. So it can't be your endpoints because those are equal. That's when these two graphs are equal to one another, these two functions are equal to one another, and you want where in between there. So we're going to use c equals 1 because it is obviously the most straightforward number to use here. And we're going to evaluate each function at c. So f of c, x squared, so 1 squared is 1, 4 times 1 is 4, minus 1 squared is 1, so 4 minus 1 is 3. So f of c is 1 and g of c is 3, and from that we can make this inequality. G of c is greater than f of c. But because these graphs only cross at 0 and 2, this will be true for all values between 0 and 2, not inclusive. So we have g of x is greater than f of x on that interval. And it's not inclusive because if we were to have 0 is less than or equal to x is less than or equal to 2, then this would no longer be true because we would have to say g of x is greater than or equal to f of x because at 0 and 2 they are equal. And we don't want to say that. That doesn't help. We want to say that g of x is greater than f of x, and so we drop the equality sign there. So what we're going to do next, now that we have this inequality, is we are going to use the shell method and the shell method formula, as we discussed above, shell. And we're going to write the volume equals 2 pi times the definite interval from 0 to 2, which is our domain, our interval, times the larger function g of x minus the smaller function f of x. Here, that's the reason we did this. And then we have 4 minus x. And the other examples I've done so far, it has just been x, because we have been rotating around x equals 0, or the y-axis. In this case, we're rotating around x equals some other value. In this case, it's 4. So for all cases except the y-axis or the x-axis, where you're rotating around x equals 0 or y equals 0, you have to take that value that you're rotating around, in this case 4, and subtract x from it and multiply it by here. So you have 4 minus x times g of x minus f of x. So I'm going to plug in g of x, and I'm going to plug in f of x, and g of x is 4x minus x squared. F of x is x squared, so it comes negative there. And from here, I'm going to combine my like terms. My negative x squared becomes negative 2x squared plus 4x, and I reordered it because I'm about to take out a negative. And I come down and I pull out not only a negative, but a negative 2, because they have a factor of 2 in common, and this is being multiplied, so I can pull out a 2 from the entire expression. So I can say positive, because I pulled out a negative, positive 1x squared, because I also pulled out a 2, minus, I boo-booed, minus, change the sign, divide by 2, 2x. And this is still multiplied by 4 minus x. Now what I'm going to do now is I'm going to undo pulling out a negative, because here my x is the highest degree, and I want it to be in front, and I want it to be positive. So what I do is I multiply this by negative 1, but if I do multiply this by negative 1, I have to multiply this by negative 1, and so this just becomes positive 4 pi times the definite integral from 0 to 2 of x minus 4 times x squared minus 2x dx. And that's where we are. From there, I can distribute. So x times x squared is x cubed. X times 2x is negative 2x squared. Negative 4 times x squared is negative 4x squared. Negative 4 times negative 2 is positive 8x. Excuse me, negative 4 times negative 2x is positive 8x. And again, we have our dx. Ready? Bam. Didn't turn over this time. So what we're doing now, do it like this. So what we're doing now is we are going to combine our like terms again. So we have 4 pi times the definite integral from 0 to 2 of x cubed, negative 2 minus 4 is negative 6, x squared plus 8x. And from here, we can't do anything more with this, and so we're going to go ahead and integrate, and we're going to get v equals, so our volume equals 4 pi times integral of x cubed is x to the 4th over 4. Integral of x squared is x cubed over 3, but there's a 6, so 6x cubed over 3 is the same as 2x cubed. And then 8x becomes 4x squared because integral of x is x squared over 2, and again, I just divided the 2 in my head, didn't think it deserved its own step, and evaluated from 0 to 2. So let's go ahead and get rid of this. Whoa. And just look at what we have right now. Okay. Actually, we'll cover, spoiler alert. Boop. Okay. From here, we can pull out this 4, because I hate fractions. So I'm going to pull out 1/4, and I have 4 pi over 4. It's just pi, it cancels. And if I pull a 4th out of here, I have to multiply these two by 4. So negative 2 times 4 is negative 8. Positive 4 times 4 is positive 16. And from here, I can pull out an x squared, because there's an at least x squared in every term. So I'm going to pull out an x squared, leaving me with, I'm just going to denote each of these powers by 2 to give me x squared minus 8x plus 16 from 0 to 2. And we can factor this. And this is actually a special factor. It is a product of perfect squares. But I went ahead and factored it longhand just to make sure everyone follows. So x squared minus 4x plus 16. I did not change the value. I just split this up into 2 negative 4s here. So if I were to add these back together, I have negative 4x minus 4x is negative 8x. It's the same. And again, from here, I can factor this part. So x squared minus 4x has an x in common. So I pull out an x, and I'm left with x squared divided by x is x. Negative 4x divided by x is negative 4. And over here, I have negative 4x plus 16. Pull out a negative 4. So negative 4x divided by negative 4 is x. And positive 16 divided by negative 4 is negative 4. So I'm left with x minus 4 and x minus 4, evaluated 0 to 2. And so I can rewrite all of this as v equals pi times x squared times x minus 4 squared, evaluated at 0 to 2. And that's pretty beautiful. So it can't get much simpler than that. So we can go ahead and plug in a 2. So 2 squared is 4. 2 minus 4 squared. And then 0 squared is 0, so this entire second term just becomes 0. And from here, it's just basic algebra. Not even algebra, arithmetic. 2 minus 4 is negative 2. Squared is positive 4. 4 times 4 is 16 times pi is 16 pi. And that's all you got to do.